Hello everyone, welcome to the OneClass channel. My name is Millen and I'm a software engineering student at Carleton University in Ottawa, Canada. Today, I will be going over some commonly asked mathematics questions at mostly the high school and maybe some at the early college or university levels. If you're interested in getting some help with your homework or if you're interested in getting some tutoring, check out the links in the description below. Cool, so to start this mathematic journey, I'll switch over to my other screen real fast and we can get this party started. Okay, so the first question on the menu today is asking us, how are parallel and perpendicular lines alike? Okay, so let's actually draw some examples of some parallel lines and some perpendicular lines so we can kind of see, well, how they're similar and how they are different from each other. So let's grab a shape so I can draw some straight lines. Okay, so parallel means that the lines are going in the same direction, okay, or in opposite directions. Parallel lines. A good thing to keep in mind about parallel lines is that if they were to continue on, they would never meet each other. Like these are an example of not so parallel lines, and you can see that like right now they're not touching each other, but like if I were to extend them in red, they would eventually cross over with each other. Okay, so this is non-parallel. And maybe some examples of some parallel lines that we see in day-to-day life. Train tracks are parallel lines for the most part. Straight train tracks, roads are parallel lines, and you would want your train tracks to be parallel lines because if your tracks would eventually get like closer and closer together, well, your train would probably not want to be on those tracks for very long. So that's an example of where you would see parallel lines in real life. And parallel lines have some really cool properties about them, like any line that goes through a parallel line like this, or a pair of parallel lines like this, these angles, I'll color code them to make them more clear. These angles are going to be the same, and the angles on the other side are going to be the same. Okay, so that's just like a cool law about parallel lines. And for perpendicular lines, let me just get my line tool right here so we can draw the straightest, most beautiful lines ever. Perpendicular lines are lines that intersect at 90-degree angles. And it is critically important that they are exactly 90 degrees. Okay, so I'm going to write here perpendicular lines. So here is 90 degrees, 90 degrees, 90 degrees, and 90 degrees. 90 degrees everywhere. Perpendicular lines are cool because they kind of remind us of like Cartesian grids, right? And you know, if we were to go like a lot about the horizontal, we could say our relative position on there. Like maybe here could be like 2, here could be 4, and our vertical, we could also have like positions along there. So if we have perpendicular lines, we can use them as like coordinate axes to define where we are with respect to everything else in the world. So you know, we see here we got 4 right angles for perpendicular lines when they intersect. Parallel lines will never intersect. That's like the fundamental definition of parallel lines. The slopes, that's another factor that we need to consider, is that the slopes are the same for parallel lines. Equal slopes. And for perpendicular lines, let me just scroll down a little bit. For perpendicular lines, the slopes are negative reciprocals of each other. Slopes are negative reciprocals. What do I mean by a negative reciprocals? A negative reciprocal is, let's say we have x negative reciprocal is negative 1 over x. So you just put it on the downstairs of your function. I mean, not of your function, of your fraction. You put it on the downstairs and you multiply it by negative 1. That's how you take the negative reciprocal. And any two lines that have slopes that are negative reciprocals of each other, 1000% never say that they're not perpendicular. They have to be perpendicular if their slopes are negative reciprocals of each other. But for parallel, they have to be precisely the same. Even if they're off by just a little bit, it's not parallel. They have to be precisely the same. Okay? And another thing about parallel lines is that they will have, they might have different y-intercepts. Or will have. They must have different y-intercepts if they're not the same line. Like technically, if I draw a line like this, and I draw like a second line, but it's like directly on top of it, they're the same line. You wouldn't. Technically, they are perpendicular, but you would want to call them like equal lines or the same lines instead of perpendicular. It's just a more descriptive way of talking about that. So we'll have different y-intercepts when not the same line and for perpendicular lines they might have the same y-intercept, but the only way that's possible is if they intersect at x equals 0. So can have the same y-intercept if they intersect at x equals 0. Otherwise, they have to have different y-intercepts. To have different y-intercepts. Okay, so these are some of the differences and similarities when we talk about parallel lines. As we know, like the definition or the equation of a line is going to look something like this. Typically, we like to use the form y equals mx plus b, where m is the slope and b is the y-intercept, also known as the base, and x is just like x value at that point, and same with y. Y is just the y value at that point. Okay, so given these factors, or given these terms in the equation of a line, we can see like just by looking at the m term, whoever is attached is multiplied with the x. That way we could, kind of figure out if two lines, if they have the same m, they're parallel. If they're negative reciprocals, they're perpendicular. And yeah, and the y-intercept, that kind of helps you position where up and down, because two parallel lines or perpendicular lines, like these are parallel and these are parallel as well. The distance that's between them doesn't particularly matter. It's just the slope that matters. So if the difference in their b terms for parallel lines is big, that's just controlled by the b, but that doesn't change the parallelness of it. And same with perpendicular lines. If they have like wildly different b values, they can still be perpendicular as long as their slope values are negative reciprocals of each other. Okay, so hopefully that helps clear up some things about the wonderful world of parallel and perpendicular lines. Very cool and very important, because these will lay down the foundation for a lot of the future math stuff that you will likely encounter in your academic journey. Okay, so let's mark this question as good. The above solution is good. Good job. High five.